So now we're going to be covering trig equations in radians. So here it says change the angle measured to decimal form. Round your answer to the nearest 3 decimal places. So here, can you guys see my screen? Is it still sharing? Okay, just making sure. So it says find two values of theta between 0 and 2 pi that satisfy the equation. So we have 2 cosine of theta minus the square root of 2 equals 0. Okay. So I did put the unit circle up here so we can refer back to it when we need to. So here, let's see, 2 cosine of theta minus the square root of 2 equals 0. So we're going to start solving for theta. So first we're going to move over the square root of 2. This cancels and we get 2 cosine of theta equals 0 plus the square root of 2 is the square root of 2. Okay. Then from there, to solve for theta, we're going to divide both sides by 2. And we get cosine of theta equals, this part cancels, and then the square root of 2 over 2. So before we do the inverse of cosine, we do need to take note that the square root of 2 over 2 is a positive number. Okay, this is going to tell me where my angles are going to land on the graph. And once we know where our angles land on the graph, that helps us find what the angles are. So because this is cosine and cosine is positive, we do all students take calculus. All of them are positive in the first quadrant, so one triangle is going to go in the first quadrant. Okay. Then we do it again. All students take calculus. Okay. That means that our other triangle is going to be in the fourth quadrant. Okay, because C stands for calculus or cosine, and that means that cosine is positive in the fourth. Okay, so once we set our triangles up, we can go ahead and move the cosine to the other side by using inverse cosine. So we get theta equals inverse cosine of the square root of 2 over 2. Okay, so I'm going to go ahead and use my Delta Math calculator. So let's see. I press functions, inverse cosine, the square root of 2. I make sure I get out of the square root before I divide it by 2 and I hit enter. Oh, I can't see because of this thing. Where do I hide it? There. And it gives me 45. I wonder where to put it. Okay. So then that means that this angle right here is between 0 and 90 degrees. And when we did the inverse cosine, it gave us 45. So that means from here to here is 45, which is our reference angle. Okay. And then this next one, we're looking for, if this angle, reference angle is 45, we are looking for this angle that comes all the way around and stuff there. So to find that angle, we're going to do 360 minus the 45, and that gives us 315 degrees. Okay. But they do want our answer between 0 and 2 pi, so I'm not going to give my answers in degrees. I'm going to give my answer in radians, okay? So I did show you guys how to change them into radians. You multiply by pi over 180, but because I have my unit circle, I am going to go ahead and use this number. So 45 is the same thing as pi over 4. And then we said 315 degrees is the same thing as 7 pi over 4. So pi over 4 and 7 pi over 4. Okay. Now, the next one here we have 2 sine of theta plus the square root of 3 over 2 equals 0. So I'm going to go ahead and solve for theta. So first I'm going to move over the square root of 3 by subtracting. It cancels here and we get 2 sine of theta equals 0 minus the square root of 3 is going to give me negative square root of 3. And then I go ahead and divide by 2. These 2's cancel, and I get sine of theta equals the negative square root of 3 over 2. Okay, this is where we have to take note. Before we use the inverse sign, we do have to take note that sine is negative. So when we make our graphs, it's going to make a difference where our triangles are located. So here, we do all students take calculus. All of them are positive in the first, and sine is positive in the second quadrant. So that means that because sine is negative, it's not going to be in the first or the second quadrant. It's going to have to be in the third and the fourth, because this is where sine would be negative. Okay. So we need to find what these two angles are from here to here, and from here all the way up to here. Okay. But we are going to need the reference angles of these triangles in order to help us find out what those angles equal. Okay. So then I'm going to go ahead and use inverse sine. So I move the sine to the other side, and I get theta equals inverse sine of the negative square root of 3 over 2. Okay, so I'm going to go ahead and plug that into my calculator. I am going to press function inverse sine of the negative square root of 3 over 2. That gives me negative 60. Okay. That means that my reference angle here is 60 degrees. So if one full circle is 360 and I take away that 60, that gives me my angle is 300. This one, if this little reference angle is 60, then I do 180 plus the 60, and that gives me 240. Okay, but in our answers, they do not want it in degrees, they do want it in radians. So I'm going to go ahead and check what is 240 and 300 as radians. 240 is right here, 4 pi over 3, and 300 is 5 pi over 3. So 4 pi over 3 and 5 pi over 3. Alright, the next one, this one says 3 tangent of theta minus the square root of 3. So we're going to go ahead and get the tangent of theta by itself. So first I add the square root of 3 to both sides. This cancels, we get 3 times tangent of theta equals the square root of 3. We divide both sides by 3. This cancels, and we get tangent of theta equals the square root of 3 over 3. Okay. Once we get to this step, we take note the square root of 3 over 3 is a positive number, and we locate where our angle theta is. Okay, so because tangent's positive, we do all students take calculus. All of them are positive in the first quadrant, so tangent must be positive in the first quadrant. Okay. Again, all students take calculus. T stands for tangent. That means only tangent is positive in the third quadrant. So our other triangle is in the third quadrant. Okay, so we are looking for this angle right here, which should be between 0 and 90. And we should be looking for this angle here, which is between 180 and 270. And so in order for us to figure that out, we need to find the reference angle, which is this little angle here. Okay. So I'm going to go ahead and move the tangent to the other side to solve for angle theta. So that means that we're going to have to use the inverse tangent of the square root of 3 over 3. So let me put that in my calculator. Functions inverse tangent of the square root of 3. I get out of the square root before I divide, and then over 3. So that gives me 30. That means that my reference angle here is 30 degrees. Okay, so that's going to be my first one. Theta equals 30. Oh, I can't write it in degrees. Sorry. I have to change it to the radians. Sorry. And then this one, we're going to do 180 plus the 30. And that gives me 210. So I'm going to look at 30 and 210. So 30 here is pi over 6, and 210 is 7 pi over 6. So pi over 6 and 7 pi over 6. Again, you can convert using the radians to degrees or the degrees to radian formula. I'm just using the unit circle because it's there. Okay, so here we have cosecant of theta plus 2. We're going to get cosecant of theta by itself first. So we have cosecant of theta equals negative 2. And then I'm going to switch it around just because we don't have a cosecant button on our calculator. So the opposite of cosecant is sine of theta equals negative 2. Okay, this is the part that we take note, well, not negative 2, I'm sorry. Negative 1/2. Okay, because we got to flip it around because cosecant is the opposite of sine. So I got to flip around the ratio. Okay, so we do have to take notice that sine here is negative. Okay, that gives us the location of our triangle. So all students take calculus. Okay, sine is going to be positive in the first and the second quadrant. So we're not looking for when it's positive, we're looking for when it's negative, because it's equal to negative 1/2. So that means that it's going to be negative in the third quadrant and in the fourth quadrant. Okay. That means that we're looking for this angle here, which is between 180 and 270, and this one right here, which is in between 270 and 360. So in order for us to figure that out, we need to find the little reference angle in here. Okay. So now we're ready to move the sine to the other side and solve for theta. So we use inverse sine of negative 1/2. I go ahead and put that in my calculator. So inverse sine of negative 1/2, and it gives me negative 30. That means that this angle in here is 30 degrees. Okay, that means this one right here is 30 degrees also. So then to find the first angle, we're going to do 180, because that's halfway there, plus the little 30. So 180 plus 30 gives me 210. This one is almost one full circle, but it doesn't complete it. It's still off by 30 degrees, so it's going to be 330. So I'm going to go ahead and make those changes to radians, 210 and 330. So 210 is right here, 7 pi over 6, and 330 is 11 pi over 6. So theta equals 7 pi over 6, and theta equals 11 pi over 6. Okay. Let's go ahead and move on to the next one. So here we get secant of theta minus 1 equals 0. So I'm going to go ahead and start off by adding the 1 to both sides. And this gives me secant of theta equals 0 plus 1 is 1. Okay. We then change it for the opposite of secant is cosine. And we flip it around. So if it's 1 over 1, we flip it around and it's still 1 over 1. Okay, which is just 1. So I'm just going to erase that. Okay, now that we got in terms of cosine, I'm going to go ahead and take note that it is a positive number, so I make my two graphs. All students take calculus. All of them are positive in the first, and because cosine's positive here, it needs to be in the first quadrant. And then again, all students take calculus. That means the other side is going to be in the fourth quadrant. Okay, so now we're going to do the inverse cosine to figure out what theta is. So I'm going to put that in my calculator. Inverse cosine of a positive 1. And this gives me 0. Okay, so this is one of those weird cases where it gives us exactly 0. That means that it is not in the first quadrant or the fourth quadrant. It's right on top of the axis, okay, which is 0 degrees. So in terms of pi, that's just 0 pi's. Okay, and then this one's only going to have one answer, so it is possible for you to get 0 or 90 or 180 or 270. Usually it doesn't say 270, it'll give you negative 90, but we know that that's also 270. So this is just one of those weird cases where it gives us the actual axis, okay? And it'll only have one answer. Okay, so then the next one, the last one, cotangent of theta plus 1 equals 0, so we move the 1. We get cotangent of theta equals negative 1. We switch it out for tangent of theta because we don't have a tangent button. So if we flip over negative 1, it's still going to be negative 1. Okay, so I go ahead and take this and I take note that it is a negative number. So when I make my graphs, we're going to look for where tangent is negative. So all students take calculus. All of them are positive in the first, and tangent is positive in the third, but we don't care where it's positive, we want where it's negative, so it has to be in the other two quadrants. So there's one there, and the other one is here. Now the angles we're looking for is this one that's in the second quadrant, which is between 90 and 180, and the one that's in the third quadrant, which is between 270 and 360, okay? So in order for us to find those, we do need to find what these reference angles are. And the way that we find them is by moving the tangent to the other side and using inverse tangent to solve for theta. Alright, so inverse tangent of -1, and take out my calculator. Functions, inverse tangent of -1 gives me -45. So that means that this angle right here is -45 degrees. Okay, because it goes in this direction, but it's just 45 in measurement. So 360 minus the 45 gives me 315 degrees. Okay, if that reference angle is 45, so is this one. So to find this angle, we're going to do 180 minus the 45, and that gives us 135. So then to find my two angles, in terms of pi, I'm just going to look it up, 135 and 315. So 135 is 3 pi over 4, and 315 is 7 pi over 4. 3 and 7. Alright, and that's it for me. If you guys have any questions, you can stay on. If not, that's it.